Hi everybody, this is Dr. Hamid with your Math 120 College Mathematics class. Today we'll cover section 2.4, okay, which is about Venn diagrams and set operations for three sets ABC. Okay. If you recall, in section 2.3, we considered Venn diagrams and set operations for two sets only. Okay. The main goal in this section is to extend those concepts we learned for two sets to consider more than two sets, three sets, four sets, so on, so on. Okay, so everything will be similar as in section 2.3. Okay, and we will basically extend the set operations and Venn diagrams to for three sets. Okay, and how will we achieve that goal? We will work in small steps. We will start, if three sets are given to you, we will work with two sets at a time. Okay, we will start with the innermost operation, and then we will work our way outwards. Okay, and then we'll to achieve the required goal. Okay, now to give you an idea how to deal with more than two sets, let's consider this example. Okay, in which we have three sets A, B, and C given to us. A universal set is also given to us. Okay, and our first task is to find A intersection with B union C complement. Okay, so this involves three sets operations with three sets here. Okay, so as I told you earlier, we will work in steps, starting with the innermost operation. Okay, and the innermost operation is finding the complement of C here. Okay, so let's start by finding the complement of C. C is this set. Okay, complement of C will be exclude these elements from U, and whatever is left over, that will be our C complement. Okay, so if you exclude 2, 3, 4, 6, 7 from this set, the remaining is 1, 5, 8, 9. That is your C complement. So we are done with this one here. Now, as I told you, we have to work our way outwards. Okay, so now let's find B union of C complement. So this is B, this is C complement. Okay, so let's combine them. Let's find the union of these two. So we have 1, 1. Okay, so let's put 1 there, combine this, 2, 3, 5, 6, 8, 9. Okay, no need to repeat the elements as I told you earlier. So we have all this parenthesis thingy here. Okay, we have B union C complement right there. Now let's move on to the last step. Last step is find A intersection with what we just found here, B intersection C complement. Okay, so this is what we are doing. We have to find A intersection B union C complement. Okay, B union C complement is given by this set here. So let's find the common elements, and common elements come out to be 1, 2, 3, 5 there. So that's what we wanted. That's what our final answer. Okay, now I opened this lecture with the example for a reason. Okay, see what happened here. Instead of having two sets, we have three sets, but at a time we worked with two sets or one set at a time. Okay, and then we put all the pieces together slowly and slowly. But the key is always start with the innermost required operation and then work your way outwards. Okay, now let's look at Venn diagram with three sets here. Okay, in this in this slide we will learn how to interpret different regions in a Venn diagram, okay, and what they really mean. So in this one here we have a Venn diagram which has three sets A, B, C, and there are different regions labeled here. 1 this white region here, 3 this white region here, 7 this white region here, 5 is the more the common to all. Okay, so we will see what different regions mean, okay, and how to interpret all those regions. So we'll work on all the regions here. Let's start with the innermost region. This region is labeled as region 5 in Roman alphabets. Okay, and this region basically represents elements that are common to all three sets A, B, and C. Okay, common to all three sets. So mathematically speaking, it's the intersection of A with B and intersection of B with C. Okay, common to all. This is this region here. Moving on to the next region, which is this 2 here. Okay, this region represents elements in both sets A and B, but not in C. Remember that we are only talking about this region 2 here. not 5. So we have to exclude this. That means we have to take the complement of C. Okay. So, mathematically, this region means A intersection of B intersection C complement. Everything but which is in U but not in C. Okay. Moving on, let's look at region 4 here. This one, that is the same story with sets A and C. Okay. So it will be, this region represents elements both in set A and C but are not in B. So it will be A intersection C intersection B complement. Okay. Similarly, region 6 here, that means, we have to exclude the elements in A here. Okay. So we will take the elements common to B and C but exclude the elements of A. So region 5 we have to exclude. So this region represents elements in both A and C that are not in set A. Okay. Moving on to region 1, this is an easy region. Okay, this region, and this region, they no overlaps there. Okay, so this region is exclusively in set A, no overlaps here. Okay, so region 1 means elements of set A which are not common to any other set. Okay, so mathematically it means, A intersection B complement and C complement. Okay, so we are excluding those two. So this region represents elements in set A that are neither in set B nor in C. Similarly, region 3 here, that means elements in set B that are not in A and not in C. Okay. Similarly, and the region 7 here, it means elements in C that are not in B and not in A there. Okay. And the last region here is region 8 is basically this region represents elements in the universal set U that are not in A, B or C. Okay, anything outside this circle will be our region 8 here. Okay, so mathematically it will be A complement common with B complement common with C complement. So basically when we talk about a complement, we exclude those elements. So we are excluding A, B and C, all three. Okay. Now let's look at one more example. In this example, okay, information is given to us in the form of a Venn diagram here. Okay, and our goal is to carry out a bunch of set operations. Okay, A, B, C, D, E, all of these set operations, which involve 2 sets, which involve 3 sets. Okay, we have to do all that. And the solution of this example, when we'll solve this example, it will be given in the form of this table here. Okay, we'll fill this table slowly. Okay, and it will be given in the form of a table where we will explicitly represent what we are trying to do here, what it means, and where it is located on the Venn diagram. For example, if we are talking about set A, okay, so set A is this circle A. Okay, so this means all elements in circle A here, and in Venn diagram it consists of region 1, 2, 5 and 4, all these regions. Okay, 1, 2, 4, 5 here. So if you want to put it in the listing form or roster form, so what do? You will list all these numbers here. So we have 11, 3 in one region, 12 in two region, 6 in fourth region, and 5 and 7 in the fifth region. So that are the elements in set A here. Similarly, if you want to put elements in A union B, that means we are combining all the elements in A and all the elements in B. We are putting all of them together. So how many regions we are talking about? Everything. 1, 2, 3, 4, 5, 6. Okay, all of those regions here. Put all the numbers together, and this is your set in the raster form. Now, if you want, B intersection C. So what are we looking for? We are looking for set elements common to B and C. So this is your B, okay, and this is your C here. So what is common to the both? Regions 5 and 6. Okay, so 5 and 6 is 5, 7, 9. 5, 7, 9. That is the raster form your solution then. If you want to find C complement, that means everything, okay, but not C. So we will exclude the elements in C there. Okay, so what will that be? That will be regions 1, all the remaining region 1, 2, 3 and 8. So we are excluding 7, 6, 5 and 4. Okay, so we are excluding that. Lastly, if we are talking about A intersection B intersection C, that means we are looking for the region, the most famous region, which is common to all, is this region fifth here. Okay, this region is common to all, and if you look at it, it has its entries are only 5 and 7. Okay, so that's how we will get information from a Venn diagram and perform different set operations. Okay, let's look at one more example here. These are examples similar to your homework problems and quiz problems. Three sets are given to you. Set A is 1, 2, 3, 4, 5. Set B is 1, 3, 4, 6. Set C is 1, 6, 7. We have to do a bunch of operations. Okay, suppose you want to find B intersection C. Okay, we have done these kind of things many times. What we are looking for here, all elements which are common in B and C. Okay, so what is common in B and C? It is 1, it is 6. That's it. Okay, this is your B intersection C. Similarly, if you want to find A union B, that means we are combining the elements in A and B. Okay, so combine elements in A and B. If you combine, no need to repeat anything. Okay, put things together. So we have 1, 2, 3, 4, 5, 6. That's A union B. Now let's look at three sets operations. Okay, we already have B intersection of C, which is this one here, and we want to unite this with A. Okay, so everything is there except 6. So put the 6 together. Okay, and this is your set with A, union B intersection C there. Okay, so this was an example similar to your homework problems in which you have to deal with three sets and find different operations. And we can put it in the form of a Venn diagram as well. These three sets are written individually, and if you put them together, that's what your Venn diagram will look like, which will show all the intersections and all that. Okay, let's look at one more example which is similar to your homework problems. Again we have three sets and a universal set given to us. Our goal is to find A intersection B complement. Okay, so if you want, first we will find A intersection of B. We're looking for those elements which are common to both A and B. Okay, so common to A and B is E. Okay, and then you find the complement of this one. I think this is the same example. I should have changed it in the last section, but anyways, so this is what it comes out to be. Okay, now this part is different. In this part we are dealing with three sets here. We have to find A union B union, the complement of the whole thing. Okay, we will start working with the innermost region here. So first we need to find B union C. Okay, combine B and C. So it will come out to be A, B, C, D, E, F. Okay, note C, A, B, D, E, F. Okay, now we want to find the complement of this. What will be the complement of this? That means we have to exclude these elements from U. Okay, so what is left? Left is just C. Okay, C is not in this one, but that's in set U there. Okay, so now we will combine this with A. Okay, so since A, C, E is in A and C is already there, so we don't have to write it twice. This is your A union B union C, the whole complement. This is your required answer. Okay, now let's look at one more time here. A Venn diagram will be given to you, and we have to use Venn diagram to write each set explicitly. So we can write it down here. Our A will be all elements in a circle, which is 1, 3, 5, 7. B will be 2, 3, 6, 7. C will be 5, 7, 6, and 4. Okay, and universal set will be combining all these bigger than that. Okay. So if we have to find A union B, we will put together all elements in A and in B. If we combine those two, they will come out to be 1, 2, 3, 4, 5, 6, 7. Okay, now if you want to find B intersection C, that means we are looking for all the elements common to B and C, which is 6 and 7. Put it right there. Okay, similarly, if you want to find A intersection B intersection C, we are looking for the innermost region, which is 7 here. Okay, if you want to find B complement, there will be all elements which are in U but not in B. Okay, that will be 1, 4, 5, 8. That's your final answer right there. Okay, let's look at, I think it's the last example here. We have to perform set operations. Again, 3 sets are given to you, and first we will find C complement. C complement will be exclude these elements from this. Okay, comes out to be 158. Next is we have to find B union C complement. So combine this with B, we get this here. Okay, this is your final answer. Last thing is with the 3 of sets, again we have to find A intersection B union C complement. Okay, so we have to find common with this and A. Okay, and it comes out to be we have 1 2 3 5 common in these 2 sets there. That's it. Okay, the last thing is the most important law in in set theory. We will not go into more detail into this one, but this law tells us if you have a complement of A intersection B and complement of the whole thing, okay, this is same as if you find the complement of each one of them and taking the union of those. Okay, you understand that? A intersection B and complement of the whole thing is equal to A intersection union B intersection. Okay, A complement union B complement. So in words, the complement of the intersection of 2 sets is the union of the complements of those sets. Similarly, if you are starting with union, if you have A union B and complement of the whole thing, this union will be converted into a intersection and then complement of each one of them. Okay. In words, the complement of the union of 2 sets is the intersection of the complement of those sets. Okay, very important results in in proving theorems and and in applications as well. Okay. Thank you very much. This was a easy lecture, short lecture. Everything was same as we had in section 2-3. In section 2-3 it was for 2 sets. Here we are talking about 3 sets here. Okay, please try the assigned homeworks in my math lab. If you have any questions, do not hesitate to contact me. Thank you. Bye bye.